Lesson 24, 3-4, interpreting graphs. The terminology here is transformation. A transformation is a change in size or position of an object. We'll be covering a couple types of transformations today. Type of transformation is a translation. A translation is a slide. Basically, each point moves the same distance and in the same direction. So translation is a slide. Reflection, also known as a flip. It is a mirror image. It is normally flipped over a line, which would normally be your X or Y axis. Other things, the max of a graph is the maximum point of the graph, the highest point. The min is the lowest point of the graph. Graphs do not always have a max or min value. The zero of a function is a value for the independent variable that makes the dependent variable zero. Basically what this is the point of intersection on the x-intercept. It is where it crosses your x-axis. The first half of lesson 24, we're going to talk about some of the max, min values, how to find the max and min, the zeros, and where the graphs are increasing and decreasing. So our first equation, we have y equals negative absolute value of x plus 1 plus 3. Absolute value is going to create that V-shaped graph. In this case, it would be inverted due to the fact that it's negative. Our max and min value. This point in our graph, a max and a min would have to deal with your rise, your up and down, how high it is or how low it is. This here would be the highest point on the graph. The highest point on the graph would be your y value. Your y axis deals with up and down. Therefore, your highest value here is 3. Your lowest value, there's your max of 3. Your lowest value, remember, this graph continues on forever. So it continues on, keeps continuing on down to the bottom. It'll never reach a minimum because it continues on forever. So basically your min here would be none because of the fact that the graph goes on forever. In part B, you're going to estimate the zeros of a graph. Okay? Remember that the zeros of a graph are basically your x-intercept, where it intersects the x-axis. So as you come along your x-axis, you would find out that your first point of intersection is right here. That would be -4. You continue along, the next point of intersection is right there at 2. So the zeros of a function, your x-intercepts, would be -4, 2. Last part, in part C, you're going to state the intervals where the function is increasing and decreasing. Now, when you read a graph, you read it from left to right, kind of like what you would read a book. So as you read along your page here, you come to your line. You need to go up. So this part of the graph is increasing. Okay? It increases to a certain point. That point, if I bring it down, -1 is my x value. So your increasing part, right here, x has to be something in relationship to 1. And the decreasing would be in relationship to 1. So all these values down here for x are negative. And actually, this would actually be -1, sorry. Because this is where that peak is, right there at -1. So on the increase, here's your increase. Your increase comes along the x, and it stops right there. So all these values back here for the increase, x has to be less than. All your x values are less than. Look at all these values right here. They're less than. So we have x is less than -1. This is where it increases. The decrease, okay, from -1, it decreases from -1. So all these x values here wind up being greater than. So on the decrease, x is greater than -1. Here's the peak. So x value of 0, still in the decrease, x value of 1, so everything greater than -1. Example 2, here's our graph. In part A, again, we're going to state the maximum and minimum values of the function. Note that this function continues on forever in this direction and continues on forever in this direction. So you're going to keep extending your y values. So there really is no max or min due to the fact that the graph goes on forever in both directions. The zeros, remember, the zeros are where it intersects the x-intercept. So x-axis, it intercepts 1, 2, 3 spots here. We should have 3 answers. If you look at this, where it intercepts at, slightly below -4, so you should not state -4. Just an estimate, about -3.7. You know it's slightly higher than halfway, so -3.7 would work. Your next intercept at -2. Finally, your third intercept, note that it is just short of 1, but slightly higher than 0.5, so 0.7. Again, those are estimates, and they're just about, it's a ballpark. Last, you're going to state the intervals where the function is increasing and decreasing. Remember, reading your graph from left to right, we hit our line. The first thing that's happening is our graph is on the increase. It increases to this point. Okay, that point is going to be your x value. Your increase and decreasing pattern is in relationship to x. What you can plug in for x to make it increase to get something out for y. So we put these values in. Your graph comes all the way down here, and it reaches that peak. That peak there is -3. So your increase has to be something in relationship to -3. Well, all these values are below -3 for x. So you would say that x has to be less than -3. All your values over here, if I put in anything over here, you're going to get part of your line on the increase. Now, from this point, right there, to this point right down here, your graph is on the decrease. So it's a decrease. This is a range. Now, we know this point here is -3. And we go down here and we figure out, well, this is just shy of -0.5. So I said -0.4. X has to be in this range. Well, what do we know about x? Well, from here down, we know that the x values are getting bigger. So from -3, x has to be greater than -3. And the greatest point it goes to is that -0.4. So x can never be greater than -0.4. So x has to be less than, showing the range between the 2 points. And finally, from the -0.4 that we have here, our graph comes back on the increase. So our x values, in order for it to get back on that increase from this point, -0.4, our x values start to become positive. So these values are going to be greater than -0.4. This concludes the first section on lesson 24.